So this is going to be our fourth video. So this is video number 4. And it's going to be practice problems. So you can get the practice problems if you want. They're available to print out. So what we want to do is we want to use the trig ratios for the reference angles. And those are 0, pi over 6, pi over 4, pi over 3, pi over 2, or 0, 30, 45, 60, and 90. To find the cosine, theta, tangent for all these. And this is the table I've made before of reference angles. And so we're going to, for each one of these, we're going to have to use one of these angles. Okay. So these are all going to be over 3s. So my reference angle is going to be pi over 3. Notice these are over 6. Reference is going to be the pi over 6, and so forth. Okay, so we'll go through all that. So I want to go through a little bit of math, which I haven't really spent much time on, to help you go through how to convert, how to figure out what 7/3 pi really is. Okay, so 7/3 pi, I think of it as 7 pi over 3s because that's a reference. So that's pi over 3 is 60. So this is going to be 420 degrees. And really what that is that's going to be over 360. And so I want to find out how much over. Well, 42 minus 360, that's going to be 60 degrees. So what this angle is going to be, I'm going to go 360, then 60. Okay. And it's a positive angle. So this is a negative angle. So I'm going to do similar kinds of things. I'm going to go, okay, this is 11/6 is going to be equal to minus 1 times 11 pi over 6. And remember that pi over 6 is 30. So that's going to be the same as minus 11 times 30 degrees. That's going to be minus 330. It's just less than 1 trip. So it's going to be 330 degrees around the circle. The circle's 360. So, okay. So that's how I figure that one out. Minus 5/2 pi. That's going to be, again, minus 5 times pi over 2. That's the reference, pi over 2. And pi over 2 is 90. So that's going to be equal to minus 450 degrees. Again, that's more than 1 trip around, but not that much longer. So it's going to be minus 90. And so what's going to happen is I'm going to go once around the circle. So I'm going to go once around the circle, 360, and then 90. Again, we'll do examples of these. Again, pi over 3 again, so this is like this one, but except it's 19 pi over 3s. And what I notice is that that for 6 pi over 3s, that's the same as 2 pi, so that's 360 degrees. So I got to figure out how many 6 pi's I have in here. So I divide this by 6, and I get 3 with 1 remainder. So what that tells me is I'm going to have 19 over 6 pi is going to be the same as 3 trips around the circle, or 18/6 pi, plus another pi over 3. So it's going to be 3 trips, and then 1 pi over 3, or 60 degrees. Okay, so I'm going to use these ideas to find the angle. So here go 360, then 60. Well, that would be going once around and then another 60. This one, it's less than 360 but negative, so I'd go minus 330. So I'd go here. That's my 330. I have 60 left. Okay, keep that in mind. Here, this is once around, then 90. So I go, but it's negative, so I'm going to go in the negative direction, and then another 90. Oh, I did this one in the positive direction, so let me do this again. This is going to be the negative direction, so I'm going to go minus 330 this way. And then I'm going to have 30 degrees left. And then for 19/3, we said that was 3 trips around, plus 1 more 1/3. It's a positive angle. That's going to be 6 pi, 3 over pi, 12, 18, 1 more, and then another pi over 3. Okay, so that's how I find the angles. So that's important, I think, to know. And then what I want to do is also, I hope this is helpful. sometimes students in past classes have found it helpful, so we'll just have to see if you do, but it's a way to keep track of where things are positive. Now this looks really messy, but I'm going to simplify it. So here, quadrant 1, cosine's positive, sine's positive, tangent's positive. They're all positive. So I'm going to go a capital A. They're all positive here. Okay. Over here, cosine's negative, tangent's negative. The sine is the only one that's positive. So I'm going to go that the sine is positive. Okay, circle that. Quadrant 3, cosine's negative, sine's negative, but the tangent's positive. So the tangent is positive in quadrant 3. And then over here, cosine's positive, but the sine and tangent are negative, so the cosine is positive. And notice this sort of, if I just look at the first letters, I get A, S, T, C. All are positive. The sine is the only one that's positive. The tangent is the only one that's positive. And the C is the only one that's positive. Over here, cosine. Okay. Now, there's a way to remember that A, S, T, C. The traditional way is all students take calculus, but I like this version. All students take pre-calculus. So that applies better to us. So again, this is just a way to remember when sine and cosine are positive. I think we're ready to go. Okay, so the first one is going to be cosine, and notice how everything is over 3. So our reference angle is pi over 3, which is 60 degrees. Again, you probably want to have all this information somewhere you can find it quickly, so you don't have to remember it. So here's the way I do that. So my pi over 3 is my reference angle. I'm dealing for the cos. So I want to draw that angle. That's pi over 3. And I notice that my xy, that's going to be cosine of pi over 3, sine pi over 3. That's what this point is going to be. I'm thinking that that's on the unit circle. And then I have to look at my chart, and I go refer to the chart, and I see the cosine is 1/2 there, and the sine is square root of 3 over 2. So that's going to be the cosine. That's the sine. And then I have to go back and check, and my tangent of pi over 3 is going to be square root of 3. I mean, all I need is the cosine here, but just kind of wanted to do that. So the first angle is going to be 4/3 over pi. So I'm just going to do that here. 4/3 pi is going to be 4 pi over 3s. That's going to be 460 degrees. So I get out my calculator and multiply, and that's going to be 240 degrees. So that's going to be 90, 90 plus 60. So here's my 90, 90, and then another 60. So that's what I have here. Sorry, that should be straight down here. So my angle here, that's not a very good picture. Let me draw it here. Here's my 240, or the 4/3 pi goes to here. And then this is pi over 3 here, so I want to have these both. So this was 1/2 square root of 3 over 2. Down here, it's going to be just these points, except they're negative because they're in the negative, the third quadrant. So here, I'm going to have the point minus 1/2 minus square root of 3 over 2. Well, that's the cosine right there. So my cosine is going to be cosine of 4 pi over 3 is minus 1/2. So I would go write that on my sheet. Okay, so that's that one. Now we're going to do minus 7/3. So I'll do that over here. So I want it minus 7/3 pi. That's going to be minus 7 pi over 3s. It's going to be minus 760 degrees, which is 420. So that's more than one time around a circle. So I subtract it from 360. Sorry, it's going to be a negative. And that's going to give me 60 degrees. So I'm going to go 360 in the negative direction and another 60. So let's do that here. Here is my 60 degree already, this one here. So I go minus 360, and then I go another 60. So I go down to here. Now remember, this is 60 degrees. This is the same angle. So we're going to have a reflection across the x-axis. So here, remember this was 1/2 square root of 3 over 2. Over here, we're going to get x is the same and minus square root of 3 over 2. It's a reflection across the x-axis because those angles are the same. So again, that means that the cosine of minus 7/3 pi is going to be equal to, I look at the x-coordinate, 1/2, the same as the cosine of pi over 3. So what we're going to see with these reference angles is it's just going to change the sign. So once we know what quadrant it is, we know whether it's positive or negative. Here, this is the quadrant where only the tangent is positive, the t quadrant. All students take pre-calculus. So the cosine is going to be negative, so it's going to be the same number but negative. Over here, we're in the cosine positive quadrant. All students take pre-calculus. Cosine's positive, so it's going to be the same. Okay. Then we do one more. We're going to do, here, let me get a fresh piece of paper. It's going to be the same idea. So we've got this one out of the way, and I want to do 19/3 pi. So what we're going to do here is, remember, all students take calculus. We're going to figure out what quadrant 19/3 pi is in and go that far. So again, 19/3 pi, that's going to be equal to, I'm going to do this in two different ways. That's going to be 19 pi over 3s. That's going to be 1960 degrees. And that's going to be, if I do my math right, that's going to be 1140 degrees. 3 times around is 108, 1080, 3 times 360, so that's going to be sorry, I'm having a blank here, 20, no, I'm sorry, 60, sorry, here, let me do that again. Okay, so that's going to be 19 times 60 degrees. That's going to be 1140 degrees. Okay, just when I do the math. So I know that 360 is 1 trip around. I double that, 720. That's 2 trips around. So 1080 is 3 trips around. So then I subtract this from 1080. I get 60 degrees. So it's going to be 3 trips plus 60. So I'm going to be right back in this quadrant. So my cosine, I should get a positive 1/2 for my answer, but let's see. So we go around once, that's going to be 6/3 pi. Go around again, that's going to be 4 pi or 12/3 pi. Go around one more, 6 pi, 1080, and then another 60. So again, this angle is going to be the same as pi over 3. The coordinate here is just going to be what it was originally for the 30. It's the same angle, so it's going to be 1/2 square root of 3 over 2. So the cosine of 19/3 pi, that's just going to be 1/2, which is the same as the cosine of pi over 3. And that should be true because we go back to the quadrant where everything's positive. Remember, the only thing that we're going to find different is going to be plus or minus, and we just need to figure out what quadrant it is to make it plus. We also need to figure out how many trips around the circle. Okay, so that's it for the reference angles for the cosine. Okay, so we got that done. So then we also, the next one was we wanted to find the sine. These are the next 3. For these 3 angles, the reference you can see is going to be pi over 6, which is 30 degrees. Okay, so let's go and do that. Again, if you want to try to do that on your own, go ahead. I think that would be a useful exercise. So again, I'm doing everything for you just to make it go a little bit quicker. That's my reference. That's 30 degrees. I want the sine for these angles. And so I draw my reference angle. Okay, so the first one's going to be 7/6 pi. And I'm also going to remember this. All students take pre-calculus. Okay, that's going to help me. So 7/6 pi is going to be 7 pi over 6. That's going to be 7 times 30 degrees. That's going to be 210. Now halfway around the circle is 180. So it's going to be 180 plus another 30. So let's go here. I'm going to put the reference angle in. Now we're going to go 180 plus another 30. So this is going to be 30 here. This is going to be 30 here. This point here was square root of 3 over 2, 1/2. Again, I just look back, when referred back to my chart to see what the cosine and sine of pi over 3 were. So this is going to be on the other side. X and y are negative here. So that's going to be these coordinates. I'm looking for the sine. The sine is y. So I'm going to get, that's going to be, sorry, that's my sine. Because it's always the y coordinate. So we see that it's minus 1/2. So the sine of 7/6 pi is equal to minus 1/2. Again, the reference angle says the sine is 1/2. All students tangent, the sine's going to be negative there. That's exactly right. Okay, so let's do minus 11/6 pi. That's going to be minus 11 times 30 degrees, pi over 6. That's going to be minus 330. So it's going to be 30 degrees short of the full circle. So let's draw that. We're going to go in the negative direction, which is here. So we're going to go all the way around here to 330. But 330 minus 360 is 30 degrees. So that's going to be the same as 30 degrees. That's going to be the same as this. So again, it's going to be the same as the y coordinate, but it's going to be the same sign since it's in the quadrant where everything is positive. So the sine of minus 11/6 pi is 1/2, and that's the same as the sine of pi over 6, because they're the same angle, you just get there a different way. Remember, the cosine and sine are determined by where you end up at that point. Okay, we have one more. We have 17/6 pi. So once you think about what you do while I call that up. So we want to find here, let's leave this one here. Let me get a piece of paper that's clear. So we can use what we did already. I'll do it similar to what I did before. We need to find the sine for 17/6 pi. So what we need to do is figure out how many degrees 17/6 pi is. Okay, so that's 17/6 pi, not theta. So that's going to be 17 pi over 6s. That's going to be 17 times 30 degrees. Now that's going to be, that's going to be 10, just doing it with my calculator. That's going to be 1050 degrees. So that's, remember that one trip around is 360. Here, I'll do it here. That's one trip. 2 trips is 720. 3 trips is 1080. So we're not quite to 3 trips. So I'm going to subtract 720. And I'm going to get 330 degrees. So I'm going to be 2 trips in the positive direction plus 330 degrees. So we got to figure out what quadrant that's going to put me in, and then we can just look at the sign here and figure out whether it's negative or positive. So here we go, 2 trips, 1, 2, and another 330. So we're all over to here. So this is 17/6 pi. What's left here is 30 degrees. Here's the original angle, pi over 6. This is just going to be another reflection. Except this time, what's going to be different is we're looking at the y coordinate, because that's what the sine is. So remember, This point was square root of 3 over 2 1/2. We reflect it. The x-coordinate stays the same, but the y-coordinate changes. That's going to be the sine. Again, it makes sense. It's going to be the same number, but it's going to be negative since it's in the C quadrant where only the cosine is positive. So here, so we get the sine of 17/6 pi is going to be equal to minus 1/2. We saw that the sine of 7/6 pi was equal to 1/2 because we ended up in quadrant 1, and we saw that the sine of minus 11/6 pi was also 1/2 because we ended up in quadrant 1. Okay, so just got a couple more of these and then we're done. Okay. So the next one is going to be, have to look back at the sheet. Sorry, I misplaced it. I have it here. Here it is. Okay. So the tangent theta, and notice everything's over 2, so our reference is going to be pi over 2, which is 90 degrees. That's going to be our reference. Okay. So I have a pi over 2 chart all figured out. And so I went to pi over 2 radians as my reference angle, and we need to find tangent of theta for theta equals minus pi over 2, 3 pi over 2, minus 3 pi over 2, and 5 pi over 2. Okay, so they're all over 2's. Okay, so my reference angle is going to be this. So there's the my 90 degree angle. It's a vertical. The cosine and the sine are going to be equal to the x and y coordinates. X coordinate 0, y coordinates 1. So I have cosine is 0, sine is 1, tangent y over x, 1 over 0 does not exist. So keep that in mind. Now what I did here is I also did the tangent of 3 over 2, but we'll get to that in a second. So these are going to be fairly easy because we're just going in increments of 90 degrees. So minus pi over 2, it's just going to be 90 degrees in the negative direction. We go here. We notice here that the coordinate is 0, minus 1. So my theta is going to be minus pi over 2. Tangent of minus pi over 2 is going to be y over x. Minus 1 over 0 does not exist. So this is going to be does not exist. Okay. Tangent 3/2 pi. Well, we did that here. I went all the way around to 3/2. Notice my coordinates 0, minus 1. Again, it's going to be the same thing. The tangent of 3/2 pi is going to be the y coordinate over the x coordinate. It's just the same angle, except we got there by a different way. So that's, again, does not exist. Okay, so let's do a couple more, and we'll be done with the tangent. So again, we need to do theta equals minus 3/2 pi. That's going to be minus 3 pi over 2. Minus 3 times 90 degrees. Pi over 2 is 90. That's going to be minus 270. That's going to be, so let's just march that out. So we're going to go in the negative direction, 1, 2, 3. So we're here. That's going to be minus 3 pi over 2. That's the same as 90 degrees. There are my coordinates, 0, 1. Tangent minus 3/2 pi is equal to y over x. X is 0 again, so it does not exist. Okay. Now we have one more 5/2 pi. Okay. And here, let me move that down so you can see a little bit better. Okay. So 5/2 pi, well, that's going to be 5 times pi over 2. 5 times 90 degrees, or 450 degrees. We subtract 360. And that's going to give us 90 degrees. So it's one trip plus 90. And guess what? We're going to end up at the same place. So here, let's go do this. We're going to end up right here. So one trip around plus 90 leaves us here. The coordinate 0, 1. same as before. Tangent theta, tangent 5 pi over 2 is going to be y over x. 1 over 0, you know the drill, does not exist. So I'm just going to kind of summarize what we did for this one. So we found that the tangent, we had to find these values. The tangent of minus pi over 2, you can refer to your sheet, that does not exist. We had to find the tangent of 3/2 pi. That doesn't exist. So we want to find the tangent of, on this page, we found the tangent of minus 3/2 pi. That was the same as the tangent of 90. Again, 1 over 0 does not exist. And then finally, the tangent of 5/2 pi, that did not exist. So do you care to take a guess? What happens if we have a tangent of n pi over 2, the tangent does not exist? Okay. So again, we'll come back to that later. Okay. I think we're almost done here. Got one more, and this one's going to be we want to find all three for these two values. Theta equals pi, and theta equals pi over 2. So let's just draw the angles. I think you'll see what's going on. So pi is 180. So we go halfway around the unit circle. The point we end at is going to be minus 1, 0. Here's the unit circle, just so you see that. So again, we're going to have cosine pi equals x minus 1. Sine pi equals y equals 0. Tangent pi y over x. 0 over minus 1, so that's 0, that exists, and we're done. So then we do 2 pi. You know what's going to happen here. Pi is 180. 2 pi is 360. That's going to be one trip around the circle, so we're back where we started. This time, that's going to be the point on the unit circle 1, 0. Cosine 2 pi equals x equals 1. Sine 2 pi equals y is 0, and the tangent of 2 pi y over x, 0 over 1 is 0. So here's our idea. The sine of k pi, 0. The tangent of any multiple of pi, 0. The cosine of k pi is either going to be minus 1 for angles like pi, etc., 3 pi. We'll see before minus pi. Or it's going to be 1 for 0, 2 pi, anytime we end up completely back where we started. Okay, so again, I just want to make sure that this stuff, you get lots and lots of practice with this. I know it's a lot of work to go through all these, and the video's kind of long. But again, since you're not having a class, I don't feel too horrible about it, though I do wish the video was shorter. Okay, thank you, and I will see you all on Thursday.